You ever wonder how a simple tap in an app makes your phone do something, well, incredible? It all starts with code. Today, we're going to pull back the curtain on C programming, one of the most powerful and influential languages ever created, to see how we can actually give instructions to a machine.
So let's start with the big question, right? We use computers for everything, but how do we actually tell them what to do? How do we get an idea from our brain onto the screen as a real action?
Well, here's the thing. Computers don't speak English, or Spanish, or Mandarin. They speak in pure logic, in numbers. So to communicate with them, we need a translator, a kind of special bridge. We call this a programming language, and its whole job is to turn our instructions into something the machine can finally understand.
So where do we start? Well, we're going to grab our digital toolbox and build our very first program. This is like a rite of passage for every single programmer. And trust me, it's way simpler than it sounds.
And here it is, the legendary Hello World program. Its job is super simple. Make the computer say hello. This is the first thing pretty much every programmer learns, which makes it the perfect starting point for us too.
So, how do we get from that block of text to a program that actually runs? It's kind of like a three-step dance. First, we write the code. Second, we compile it. And third, we execute it. Now that middle step, compile, that's where the real magic happens. Let's take a closer look.
So what on earth is a compiler? You can think of it as this super smart translator. It takes the C code that we can read and write, and it turns it into the only language the computer's brain, the processor, actually gets, a stream of ones and zeros.
And once that compiler does its thing and we run the program, bam! Success! Our instructions were understood. Hello World pops up on the screen. We've officially talked to the machine. How cool is that?
So what did we actually write? Let's break it down real quick. That hashtag include line, it's like grabbing a toolkit of useful pre-written code. Void main, that's the official starting line, where the program kicks off. The curly braces, they basically hold all of our instructions. And printf is the specific command we used to print our message.
Awesome. We've told the computer to do something. But what about remembering things? I mean, most programs need to work with information, right? Like numbers, names, scores. So where do we keep all these materials while we're working?
The answer is something called a variable. And honestly, the best way to think about it is just as a labeled box inside the computer's memory. We give the box a name, and then we can pop information inside it to use later on.
Now, these boxes come in two main flavors. A constant is like a box that's locked shut. Its value never, ever changes, like the number of days in a week. A variable, though, that's a box we can open up and change what's inside, like storing your age, which, changes every year.
This is really important. We also have to tell the computer what kind of data each box is going to hold. We call this a data type. So if we're storing a whole number, we use int. For a number with a decimal point, we use float. And for just a single character, we use char. So why do we do this? It helps the computer save exactly the right amount of memory space, which keeps our program running nice and fast.
Okay, so we have our tools and we have our materials, but how do we build something smart? A program needs a blueprint, right? A way to make decisions and to repeat actions. This is where the real power of programming kicks in.
Let's start with a simple decision, using an if statement. Think of it like a fork in the road for our code. The program asks a simple true or false question. If the answer is true, it follows one path and runs some code. If it's false, it just skips that bit and keeps on going.
But what if we want to do something specific when the condition is false? Well, that's exactly what if-else is for. It gives our program two clear paths, one for true and a totally different one for false. This is absolutely crucial because it lets our programs react intelligently to all sorts of different situations.
Making decisions is powerful, for sure, but being efficient is just as important. I mean, imagine you needed to print hello 1,000 times. You wouldn't want to copy and paste that command over and over again, would you? Of course not. And that's the exact problem that loops were invented to solve.
A for loop is just a brilliant tool for automation. It basically has three parts: a starting point, a condition to check if it should keep going, and a step it takes after each time it runs. So the code inside the loop will just run over and over and over until that middle condition finally says, okay, we're done.
All right, we've covered the tools, the materials, and the blueprints. So now let's put it all together and see how these simple building blocks can combine to create a program that actually solves a real problem.
So here's our challenge. Let's say we give the computer 3 different numbers. How can we write a program that figures out which one is the biggest? This is going to require us to store some data and make a few decisions.
And here's the solution in C. Now don't get bogged down in every single character here, just look at the main parts. We've got variables to store the numbers, we use a command called scanf to get the numbers from the user, and then we use a chain of if-else statements to compare them and find the biggest one.
Let's map this right back to our building blocks. We used int variables to hold our numbers. We used scanf for the input. We used that if-else structure as our conditional logic. And finally, we used our old friend printf for the output. See how they all just fit together to solve the problem?
And you know, that's really it. Variables to store data, conditional logic to make decisions, and loops to handle repetition. These are the absolute core building blocks of not just C, but of almost every programming language out there. They might seem simple on their own, but together, you can build nearly anything you can imagine. So the only question left is, what are you going to build first?